Every program running on your server is a process. A process is a program that has been loaded into memory and is currently executing. Your Node.js app is a process. Jinx is a process. Actually, it's multiple processes. The SSH connection you're using right now is a process. Each process has a unique number assigned by the operating system called a PID, a process ID. PIDs are assigned in order, starting from 1. PID 1 is always the init system on modern Ubuntu, that's systemd. Every other process on the system was started by another process, creating a tree of parent-child relationships. Understanding processes is critical for server administration because processes are what actually run your application, consume your CPU and memory, hold your network connections open, and when they misbehave, need to be stopped or restarted. The mental model: every time you run a command, a new process is created. It runs, does its work, and exits. Long-running processes like your Node.js server or Jinx don't exit, they keep running until you tell them to stop. These are called daemons or services. Knowing how to see what's running, how to find a misbehaving process, and how to stop it cleanly is essential operational knowledge for anyone managing a production server. The primary command for viewing processes is ps, short for process status. On its own, ps shows only the processes in your current terminal session, which isn't very useful. The flags you actually want are ps auxiliary. Though a flag shows processes from all users, not just yours. The U flag shows user-friendly output with usernames instead of numeric user IDs. The X flag includes processes not attached to a terminal, which is where all your server daemons live. The output of PSAUX has several important columns. User is the user running the process. PID is the process ID. %CPU and %MEM show resource consumption. Stat shows the process state. CMD shows the actual command that was run. In practice, you'll almost always use PSAUX combined with grep to find a specific process. PSAUX grep Jinx finds all Jinx processes. PSAUX grep node finds your Node.js processes. PSAUX grep server.js finds the specific Node.js app running server.js. Reading the stat column tells you a lot. R means running, actively using CPU, S means sleeping, waiting for something. This is normal for most server processes. Z means zombie, the process has exited but its parent hasn't acknowledged it yet, usually a bug, and T means stopped. PSAUX is your snapshot of what's running right now. For live updating, use top or top. While PS gives you a static snapshot, top gives you a live, continuously updated view of your server's processes and resource usage. Run top and you'll see it refresh every few seconds. The header section at the top of top's output is packed with information. The first line shows system uptime and the number of users logged in. The second line shows the number of processes and their states, how many are running, sleeping, stopped. The third line is the critical one, CPU usage, broken down into user processes, system processes, and idle time. Then you see memory usage, total RAM, used RAM, available RAM. Below the header is the process table, sorted by CPU usage by default. The column layout includes PID, user, CPU %, memory %, and the command. Processes are sorted so the most CPU-hungry ones are at the top. Keyboard shortcuts inside top: press M to sort by memory usage instead of CPU. Press P to return to CPU sorting. Press K then enter a PID to kill a process from within top. Press Q to quit. Top is top with a much better user interface, colored output, mouse support, and easier navigation. Install it with sudo apt install top. In top, you can navigate to a process with arrow keys, press F9 to send a kill signal, and F10 to quit. For quick checks, top is always available. For comfortable exploration, install top. Despite its name, kill doesn't just kill processes, it sends signals to them. Signals are a way to communicate with running processes. The kill command sends a signal to a process identified by its PID. The most important signals, SIGTERM, signal 15, is the polite termination signal. It asks the process to shut down gracefully, finish what it's doing, close files, clean up. Most well-written applications handle SIGTERM and shut down cleanly. Kill 1234 or kill -15 1234 sends SIGTERM to process 1234. SIGKILL, signal 9, is the forceful termination signal. The process cannot catch or ignore it, the kernel immediately terminates it. Use this only when SIGTERM doesn't work. Kill -9 1234 sends SIGKILL. Be careful, killing a process with SIGKILL gives it no chance to clean up, which can leave corrupted files or unreleased resources. SIUP, signal 1, traditionally meant the terminal hung up, but now many daemons use it as reload your configuration. Kill HUP 1234 or kill -1 1234 tells many services to reload their config without restarting. This is what Nginx reload ultimately sends. Killall sends a signal to all processes with a given name. Killall Nginx kills all Nginx processes. Killall -9 node kills all node.js processes immediately. Kill is similar but matches on process name with more flexibility. Killf server.js kills any process whose command line contains server.js. Every process on Linux, except PID1, was started by another process. The process that starts another is called the parent, and the one that was started is the child. This creates a tree structure rooted at PID1. This matters for several practical reasons. When you kill a parent process, what happens to its children depends on how they were set up. In some cases, the children are also killed. In other cases, they become orphaned and are adopted by PID1, systemd. Zombie processes appear when a child exits but the parent hasn't called wait. To acknowledge it, the process shows up in PS with state Z. Stree shows the process tree graphically. Stree P shows process IDs alongside each entry. You'll see systemd at the root, with Nginx, SSHD, PM2, and other services branching off. Your node.js processes will appear as children of PM2. This tree structure explains why starting PM2 and having it manage node.js is better than running node.js directly. If your terminal session ends, or the SSH connection drops, processes started in that session may also stop. PM2 as a daemon lives independently of your SSH session, it won't stop when you log out. When debugging a stuck process, checking whether it has zombie children, via psaux grepc, can reveal parent processes that aren't properly cleaning up after their children. Port conflicts are among the most common server problems. You try to start your app and it says edrinus address already in use. Another process is already listening on that port. How do you find out which one? SS is the modern tool for this. SS stands for socket statistics and it's faster and more informative than the older netstat. The command you want is sstlnp. Breaking down those flags, T means show TCP connections, add you for UDP2. L means show listening sockets only processes waiting for incoming connections. N means show numeric port numbers instead of service names. P means show the process using each socket. The output shows the state, listen, the local address and port, and in the process column, the name and PID of the process listening there. For example, listen 0128.0.0.0.0:80.0.0.0 asterisk users Nginx, PID equals 1234 FD equals 8, means Nginx with PID 1234 is listening on port 80. If you see your app's port already in use, this command tells you exactly what's using it. lsoft 3000 is an alternative, it shows which process is using port 3000. lsoft stands for list open files, and since network connections are files in Linux, it works for ports too. These commands are essential for diagnosing port already in use errors and for verifying that your app is actually listening on the expected port after startup. When you run a command in your terminal, it runs in the foreground, your prompt doesn't return until the command finishes. For long-running processes, you want them to run in the background. The simplest way to background a process is to append "and" to the command. Node server.js and starts the node.js server in the background and immediately returns your prompt. You'll see the process's PID printed, and you can continue using the terminal. However, there's a critical problem with this approach. When you close your terminal or your SSH connection drops, background processes started with and may be killed. This is because they're still associated with your terminal session. NoHop, no hangup, solves this. NoHop node server.js and starts the process in a way that's immune to the HUP signal that's sent when your terminal closes. The output is redirected to a file called nohop.out by default. But here's the honest truth, both N and nohop are poor substitutes for a proper process manager. They don't restart on crash. They don't survive reboots. They don't give you log management. They're fine for a quick test, but they're never appropriate for production. For production, you want PM2, which we'll cover in the next module. PM2 provides proper demonization, crash recovery, startup on boot, log management, and monitoring. Use nohop only when you need a quick one-off background task and know it's temporary. When your server feels slow or unresponsive, the first diagnostic step is to check what's consuming CPU and memory. 3 tools, top, free, and uptime. In top's output, the %CPU column shows the percentage of total CPU capacity a process is using. A node.js process showing 100% CPU is a sign of a busy event loop or an infinite loop bug. Nginx workers rarely show high CPU unless you're serving a lot of traffic. If Nginx is CPU bound, you probably need more workers. The load average shown in top's header, and by the uptime command, is a number you'll see everywhere in server monitoring. It represents the average number of processes wanting CPU time over the last 1, 5, and 15 minutes. On a single CPU machine, a load average of 1.0 means the CPU is fully utilized. On a 4-core machine, a load average of 4.0 means full utilization. Load averages above the number of CPU cores indicate the system is overloaded, processes are queuing for CPU. Free H shows memory usage in human-readable format. The key column is available, not free. Available accounts for memory that's currently used for disk caching but can be reclaimed instantly if needed. Only worry if available is genuinely low. For per process memory, PSAUX sort equals %NEM head -10 shows the 10 most memory-hungry processes. If your Node.js process's RSS resident set size is growing unboundedly over time, you have a memory leak. Let's walk through a real scenario. Your server is running slow. USSH in and start diagnosing. First, check the load average. Uptime shows load average 8.43, 7.21, 6.15 on a 2-core machine. Load of 8 on 2 cores means you have 6 processes waiting for CPU at any moment. Something is wrong. Step 2, top shows a Node.js process using 99% CPU. Something's in a tight loop. Note its PID. Step 3, grep in your logs to see what that process was doing. PSAUX grep PID shows the command. Check /var/log for recent errors. Step 4, try a graceful termination first. Kill PID sends SIGTERM. Give it 10 seconds. If the process is still there and still burning CPU, it's stuck and not responding to signals. Use kill-9 PID to force kill it. Step 5, after killing it, check whether PM2 restarts it automatically. If it crashed in a loop, PM2 will show a high restart count. Check PM2 logs to see what's causing the crash. Step 6, if you see zombie processes, PSAUX grep, find their parent with PSO-PID equals zombie_PID and check if the parent is misbehaving. Restarting the parent usually clears zombies. The systematic approach, load average, then top, then logs, then kill, then verify, solves 90% of runaway process situations. A final question to lock in your process knowledge. Your server's load average is very high. You run PSAUX and see a Node.js process consuming 100% CPU. Which is the correct sequence of actions? Option A, immediately kill-9 it. This is premature, you haven't checked if it's actually stuck versus legitimately busy, and force killing gives it no chance to clean up. Option B, run kill PID first, wait 10 seconds, check if it stops. If not, then kill-9 PID. Check logs to understand the root cause. This is the correct answer. SIGTERM first for graceful shutdown, SIGKILL only if SIGTERM doesn't work, then investigate the cause so you don't just reproduce the problem. Option C, reboot the entire server. Massively disruptive when a targeted process kill would solve it. Option D, do nothing, high CPU will resolve itself. Almost certainly not true for a runaway process. It will just keep burning CPU until it's stopped. The answer is B, SIGTERM first. Wait. Then SIGKILL if necessary. Then investigate. This discipline, graceful shutdown before forced shutdown, prevents data corruption and resource leaks. And investigating the root cause means you fix the problem rather than just hiding its symptoms. Next up, Module 2 PM2. Now that you understand processes, we'll see how PM2 manages Node.js processes in a way that makes them production reliable.